my name is Debbie and this is my lab report for the first lab of Physics 2212 charge tapes. In this lab, we attempted to determine the charge on a piece of tape by observing the interactions it had with objects of known charge. The fundamental physics principles we used in this lab were Coulomb's law that opposite charges attract one another and like charges repel each other. We also used our knowledge of electric fields and electric forces caused by these fields, as you can see in the equation below, where Q is a charge of an object, R is the distance between the two charges, and K is the constant of 9 e to the 9 newtons meters squared over coulombs squared. We also used our knowledge of Newton's second law, which says that the force is equal to the mass of an object times the acceleration. We used this to calculate the gravitational force acting on a piece of tape after we observed that it was floating. We then said that the net force acting on this tape must have been 0, so the force of gravity was equal but opposite to the force of the electric caused by the electric field of the other piece of tape. In this sense, we were able to work backwards from the known force of electric field in order to determine the charge of a singular piece of tape. Like I said, the purpose of this charge was to determine the charges on a piece of tape that was caused by the motion of pulling apart two pieces of tape. We balanced the gravitational and electric forces in order to calculate the electric force. We then used a formula that I will show later on to calculate charge based on this electric force. We then determined the amount of electrons lost as a ratio to the total amount of electrons on the tape. We used the surface area of the tape and the surface area of an atom which we were given. We calculated the electrons lost by dividing the total charge of the piece of tape over the charge of a singular electron. I then used Glowscript in a Glowscript code to calculate all of this computationally using the computer code, and then compared the findings of both models for accuracy. The process that we used was to pull apart two pieces of tape and observe the charge caused by this motion. We did this by holding the charged tape near a neutral object in my hand and observed how it moved. Then we held both pieces of tape near each other, and as the pieces of tape repelled each other and both attracted or moved towards the neutral object, we assumed that both tapes had equal charges. Not equal charges, like charges. We then held the charges near a negatively charged object, a pen, which I negatively charged by rubbing against my hair, and found that they attracted each other, which gave us indication that these tapes were positively charged. We then looked at a floating tape model. So we attached one charged piece of tape to two textbooks so it was kind of suspended between them, and held the other tape near the suspended piece of tape and recorded the distance that the tape floated. My findings in my experimental model were based on the tape length of 0.192 meters that I used and the mass of the tape, which was 0.192 grams. And then my recorded floating distance that I observed was approximately 0.002 meters. So the force of gravity on the floating tape was the mass of the tape times gravitational constant, and because we said that the electric force was equal but opposite to this, our electric force on the tape was also equal to 0.0019 newtons. I then used the equation as you can see below, and I rearranged the equation for the force of the electric field in order to determine the electric charge on one piece of tape was approximately 9.19 e to the negative 10 coulombs. I then calculated the fraction of electrons given up or deficient electrons by dividing the charge by the charge of one electron, and then used the surface area of the tape over the surface area of a singular atom to determine the total number of atoms on a piece of tape. I divided the deficient electrons by total atoms to get a ratio of deficient electrons to total atoms of about 1.1.8 e to the negative 8. I used the assumption that tape is a rectangle in shape. The atoms were spread evenly across the tape pieces, and I assumed the only forces acting on the tape were force of gravity and electric force. This is just a copy of my Glowscript code that I will link down below. However, as you can see, I used very similar equations in my Glowscript code. Actually, I used the same equations in order to determine my results. As you can see, the results here are shown below. The image on the right is a little difficult to see, but when magnified, you can see the red, which is the electric charges, the electric forces, and then the orange, which is the gravitational force acting on the 2 point charges, and I used point charge to model each piece of tape. As you can see in my comparison, my results were very, very similar. The charge of the tape came out to be about 9.1 or 9.2 e to the negative 10 coulombs, and the ratio of deficient electrons to total atoms was 1 to 1.2 e to the negative 8. Additionally, what if the electrons had a positive charge and the protons had a negative charge? Essentially, not much would have changed, as long as Coulomb's law of like charges repel and opposite charges attract still still holds true, then my findings and my numerical findings would not have changed, but the difference would be that the charges observed would be opposite in sign. Also, why was it important that I handle the charge tapes as little as possible? Well, it was very important to reduce any interaction the tape would have with other objects, because as soon as it would touch an object, a transfer of charges would occur, and this would return the tape to its original uncharged or neutral charge state. Therefore, we would no longer be able to observe this floating sensation. We would not be able to calculate our results. Thank you.